Astronomers stationed beneath the silent, ink-black skies of Hawaii have just released what many are calling the most structurally revealing imagery ever captured of the interstellar visitor known as 3I Atlas. These aren't polished multi-million-dollar observatory products. These are raw, unfiltered images taken by amateur astrophotographer Kalapa Stars from Honoka, Hawaii. Images so clear, so detailed, so impossible, that they've pushed an already controversial object further into scientific uncertainty. And here's the part that has the astronomy community buzzing. Backyard astronomers across the world are now seeing things that shouldn't be possible. A half-meter telescope in rural Japan, a 315mm reflector in Spain, equipment you can literally buy online. Yet these observers are resolving structural features at 300 million kilometers, features that raise a single unsettling question. If amateurs are seeing this clearly, what are the professional observatories seeing that they're not showing us? Because these new images, they don't resemble any comet we've ever photographed. Not Hale-Bopp, not Hyakutake, not NERYs. Not even the more exotic interstellar objects like 2I Boreas. Instead of a typical coma, tail and diffuse halo, 3I Atlas appears as a concentrated blur of light, with a razor-thin jet stretching nearly 1,000,000 kilometers, straight toward the sun. A configuration that should be obliterated instantly by solar wind. The closer December draws, the harder it becomes to fit this object into any known category. So if you're watching this, brace yourself, because the next 18 days may force us to rewrite comet science, or confront the widening gap between what is observable and what is being explained. Let's break open what independent observers are capturing, because this is where the story shifts from strange to impossible. Mitsunori Shimura, in Japan, pointed his half-meter telescope at 3I Atlas, a device large for amateur astronomy, but nothing compared to professional observatory. And yet he produced perhaps the cleanest image yet of the anti-tail, revealing a slender, almost engineered column of material extending straight sunward, distance 300 million kilometers, nearly twice Earth's distance from the sun. The main dust tail, 5 million kilometers long, behaves as expected, solar radiation pushing debris backward. But the anti-tail, 1 million kilometers, pointing directly into the solar wind, maintaining form, resisting dispersion. This is the anomaly. Across the planet, Peter Carson Lee, in Spain, aimed a 315mm instrument, barely larger than a commercial celestron, and captured the same impossible geometry, different country, different method, same unmistakable structure. These aren't billion-dollar space telescopes. These are enthusiasts, people who don't answer to committees, PR departments, or data release protocols. Yet the structures they're detecting refuse to match official models. And here's the scientific kicker. Once multiple independent observers capture identical features across different loci, equipment types, and atmospheric conditions, you can't dismiss it as equipment error. You can't blame calibration. You can't hide behind processing artifacts. This is how science separates illusion from reality. And the reality forming here suggests 3I Atlas is not behaving like the comets we know. Now look closely at the November 21st image taken by Paul Craggs. At first glance, it doesn't resemble a comet at all. Instead of a bright nucleus surrounded by a foggy coma with a sweeping tail, it looks like a compact mismatched smear of motion, something between a point source and an elongated blur. Craggs himself notes the possibility of motion smearing. 3I Atlas is racing through the sky, and long exposures can warp its profile. That's honest. That's responsible. But even when motion blur is accounted for, none of the dozens of images gathered over 5 months reveal the classic comet profile we expect. Where is the broad, fan-shaped dust tail? Where is the gentle curvature? Where is the coma behaving like vaporizing ice? Instead, 3I Atlas appears as a stubborn point of light with a persistent anti-tail, something that defies our understanding of solar radiation interaction. It is not a comet behaving like a comet. It is a comet behaving like something else. And the amateur images continue revealing extraordinary details. In one frame, observers captured NGC 454, a barred spiral galaxy located 23 million light-years away, sitting quietly in the background. This galaxy was visible not because 3I Atlas is faint, but because imaging the object requires exposure levels capable of reaching deep into intergalactic space. Think about that. To capture an object in our own solar system, we are using imaging settings that simultaneously detect a galaxy hundreds of millions of light-years behind it. And even at this distance, Even at this sensitivity, 3I Atlas refuses to fade. Standard comet dynamics demand dimming as the object moves farther from solar influence. Sublimation decreases, gas production drops, dust tails shrink, the coma thins. This is predictable, tested, and governed by straightforward physics. But 3I Atlas is maintaining structure at 300 million kilometers, twice Earth's distance from the Sun, and amateurs are still resolving features. That isn't normal, not even close. This brings us to timing. Earth and 3I Atlas are approaching their closest convergence on December 19th, just 1.8 astronomical units apart, about 70 million kilometers. Still distant, yet close enough for instruments to reveal far greater detail. If amateur telescopes can pull this much structure at 300 million kilometers, imagine what they'll see at 70 million. Imagine what Hubble, Webb, Kayak, Subaru, VLT and other major observatories are seeing right now. Because here's a truth no one likes talking about. The clearest images of 3I Atlas over the past month have come from independent observers, not institutions. Mars orbiters like Horizon Maven were expected to capture breathtaking close-pass images, high-resolution, professional-grade data. Instead, what we received was surprisingly underwhelming, far lower detail than what backyard observers achieved from Earth. That raises questions, not of conspiracy, but of priorities. What data is being archived? What data is being withheld? What observation windows were chosen or bypassed? We don't know. We might not know for a long time. But here's what we can say. Everything we understand about comet behavior, sublimation, rotation, plasma dynamics, dust distribution, predicts chaotic, flickering, uneven outgas. Comets tumble, jets sputter, the coma fluctuates, and the dust tail shifts with solar wind. 3I Atlas isn't doing any of that. Its anti-tail is steady, coherent, organized, stable over weeks. Brightness pulses every 16 hours, matching its rotation period. But the change is too dramatic for a small icy nucleus. Something else is happening, something we've never seen before. The jet patterns documented by observers in Hawaii and Thailand reveal something that shouldn't exist on a simple frozen body from deep space: symmetry. Not random eruptions, not chaotic bursts, but repeating structures that hold their geometry across multiple rotations. That alone separates 3I Atlas from the behavior of every comet in the standard textbooks. And that's the theme emerging after 5 full months of imaging. 3I Atlas simply does not resemble the great comets of recorded history. Not Hale-Bopp, not Hyakutake, not Inirwise. None of them. Different shape, different activity, different light curve, different physics. But the strangeness isn't limited to telescopes pointed from Earth. When 3I Atlas swept past Mars, some researchers began combing through rover archives. Perseverance, Curiosity, even orbital imagery, hunting for anything that might correspond to the timing of the flyby. The reasoning was simple. If 3I Atlas is more than a natural object, if it's carrying fragments, clusters, or smaller bodies that behave independently, then Mars would be the ideal place to deploy them. Why? Because Mars is the only world besides Earth with active human infrastructure. Rovers, landers, orbiters. If something were studying our technology, observing from a distance, or gathering environmental data, it would make sense to release it near the only alien machines operating on another planet. Now, to be absolutely clear, no one is claiming anything definitive landed on Mars. What is happening is this. Independent groups are scanning publicly available rover photos, cross-checking timestamps, comparing atmospheric readings, and correlating them with the 3I Atlas flyby window. And at least one frame surfaced that demands more analysis. That breakdown is coming in a future report. But the bigger point is this. When official sources avoid providing the level of detail the public expects, amateurs step in. They dig through data releases, analyze raw files, bypass institutional bottlenecks, and publish findings without waiting for a committee to approve the narrative. That's exactly what we're watching unfold with 3I Atlas right now. Zoom out for a moment and consider the pattern. Observers across multiple continents, using entirely different telescopes, operating at different elevations, climates and processing pipelines, yet all capturing the same anomalies. An anti-tail that shouldn't exist, a jet that stays narrow when physics says it should disperse, brightness cycles that don't match coma-dominated behavior, a morphology that doesn't resemble any comet on record. Meanwhile, the professional observatories remain unusually quiet. and the explanations provided so far simply don't address the full range of what is being observed. That is not an accusation, it's an observable fact. The images are public, anyone can replicate, and the object does not behave like a standard comment. Now we're entering the decisive window. Earth's closest pass, December 19th, is approaching fast. This will be our best imaging geometry since Hubble's earlier capture. This time, every professional facility capable of high-resolution tracking, ground-based and orbital, is preparing for observation. And amateur astronomers, they're already locked in. The next 3 weeks will deliver sharper structural detail, cleaner spectroscopy, high-resolution light curves, day-to-day jet evolution, anti-tail stability measurements, rotation-linked brightness modeling. If 3I Atlas is ultimately a typical comet wearing an unusual disguise, then this is where the illusion breaks. The anti-tail should collapse, the jets should scatter, the brightness should diminish in predictable way. But if the anomalies persist, if the jet never disperses, if the anti-tail continues to defy solar wind, if the brightness curve refuses to behave like natural outgassing, then we are dealing with something that requires either new interpretations of cometary physics or a re-evaluation of the object's entire classification. Either outcome is groundbreaking, but here's what you should watch closely. How amateur images compare to official releases. Which data gets highlighted versus quietly archived. The lag time between professional observations, publication. The contrast between raw independent captures and curated institutional statements. Because for 5 months now, the most revealing images of 3I Atlas haven't come from billion-dollar telescopes. They've come from backyard observers, people with half-meter scopes and no one telling them what they can or can't publish. And this taps into a larger truth. When institutions release only polished summaries, while independent observers publish raw data in real time, the center of the scientific conversation shifts. Peer review takes time. Public relations messaging has guardrails. Funding requires caution. But amateur astronomers, they post what the sky shows them. And right now they're leading the global discussion on 3. NASA's recent updates have felt more like narrative shaping than scientific exploration. Minimal focus on anomalies, broad language about expected behavior, and revised trajectory models without transparent explanations. That isn't openness. That's controlled frame. And people absolutely notice the difference. Here's where things stand now. 18 days to closest approach. The imaging window is opening. Every capable telescope will be watching. Data will be pouring in, unfiltered and unedited. Independent observers will publish instantly. The global astronomy community will analyze in real time. And the big questions will finally be answered. Does the anti-tail collapse or persist? Do the jets scatter or remain laser sharp? Does the brightness fade as expected, or continue breaking the rules? We're about to find out. Don't rely solely on official press conferences to tell you what is happening. Follow the independent data streams. Compare the raw images. Watch how the object behaves versus how it's described. Because the clearest view of 3I Atlas isn't coming from billion-dollar observatories bound by release schedules. It's coming from determined observers with backyard equipment and the freedom to publish whatever their sensors capture. Stick with this channel. Over the next 3 weeks, we're breaking down every frame, every data point, every anomaly. No filters, no spin, just the sky, and what it reveals. The December window is opening now, and whatever 3I Atlas truly is, we are about to see it more clearly than ever before. Stay curious, this story is only beginning.